yeah, let's try to understand the problem first. So let's use this example 1. So we have the buildings. So 1 represents the buildings. So we have the separate buildings in each of the cell. Yeah. So the buildings is only in one grid. Yeah. If this is the whole grid, it is in one subgrid in XY position, XY coordinate. Yeah, it cannot be 2 or 3 or 4. Yeah, and also for the land, it is only in one position of the grid. It can be X and Y coordinates. And 2 means just obstacles. So first of all, I'm gonna use the BFS to solve it. So the BFS will be like the brute force. It will go from the land to all the buildings. So for example, for this land, this is a 0. It will go to 1, 1, and 1. It's gonna check the distance. And for this 0, it's gonna check like 1, 3, and 3. It is 7. First of all, let me make a drawing of this solution. So we have an area. So we're gonna check this problem in this area. So there will be some obstacles. For example, this is 2, means obstacles. Or there may be some buildings. For example, this is 1. Let me make a 1. And other areas, if I didn't make it, so this black areas is all the land. Yeah, maybe here is another building that is 1. Here is another building that is 1. So first of all, I'm going to check all the land areas. Yeah, just imagine there are few buildings and more land. As you can see from the area, there are more land. This is the common sense. But if I solve it from the land, I will check it row by row, column by column. I will check each of the subgrid. So for example, this is a land. Yeah, and in this area, I'm gonna check the distance. It is the Manhattan distance from here to there, and this land to this one, and this land to this one. Of course, it is not straight. Yeah, if it is a BFS, it would be, yeah, it would be something like from here or from here. Yeah, it would be something like that because this is the obstacles. Yeah, so this is the brute way to solve it. Yeah, but in the brute way, normally it will be time limit exceeded. Yeah, even I optimize the code, it will be time limit exceeded, but we can check something else. So for example, this is the obstacles, it is a 2. But what can be something inside? For example, inside this 2, there will be some zeros. Do we need to check all these zeros? No, we don't. So for this one, we can save some time. So if inside the obstacles, this circle is 2, and then inside there's some zeros, we need just to check one time. If for one time we find a 0, it cannot find 3 buildings because in total we have 3 buildings. So in all these areas, we're gonna set it as a 2. So all these areas will be set as obstacles because this 2, because the land is surrounded by obstacles. It means these areas can never reach a building. Yeah. Or it can be some other cases. So let me make another case. So yeah, this is let me just use this example. Yeah. Or there will be some other cases. For example, let me make another case. So for example, this is a building, and this area is always B1, and this is a building. Yeah, and this area is just land. It is a blank. It is a 0 land. Yeah. But if there is another building, for example, it is similar like that. So it's gonna be 1, and here will be 0. So can this land reach these buildings? Yeah, because this land can reach these buildings, but can this land reach these buildings? Of course not. Yeah, so if something like that, I will set all of that to be obstacles. I just need to check one time by using BFS. I don't need to check so many times. So in this way, I can save time and yeah, let this kind of a solution pass, because this is the first method. Just we are using brute force, we are check each of the land to all the buildings. Yeah. And the second way is we're gonna check from the buildings to the land. Yeah, this gonna be a little bit harder. I'm gonna explain it later. But let's try the first method first. Yeah. So I'm gonna use some coding from before. As you can see, I got a time limit exceeded, and I optimized, and some of them passed, some of them didn't. Yeah, but I tried to copy some code from before. Yeah, let me just copy some code from before. So this is the first method. Yeah, but this one will get time limit exceeded. Let me put the directions inside because it doesn't matter. Yeah, and let me explain the code. So I prepare the row and column, and I prepare a target. This target is just the sum of all the ones. Yeah, because I want to check. So for example, in this image, there will be 3 ones, so the target will be 3. Yeah, because finally, I'm going to check the count, if it is equal to target or not. If it is equal to target, it means this area, this land can reach all the buildings. I can return a result. Yeah, otherwise, yeah, let me just comment these areas. Otherwise, I will return an infinity. It means some of the land can never reach all the buildings. Yeah. And here is basically the BFS. So for BFS, for each of the areas, I put it inside. I put the R and C inside, and 0 is the distance. And I also prepared a weighted set. And here I prepare a result because I need to return this result. It is the total distance, and another one is count. This count is to count how many buildings I can reach. And basically, this area should not be so difficult. It is just a template BFS. So I just pop it out and check all the directions. So if the grid row and column equals to 1, it means I've already found a building. So the result would plus D plus 1, because D is starting from 0. So it should plus D and plus 1. So this is one of the distance. I would plus all of the distance. Yeah. And I also need to put it inside a weighted set. Because if I find one distance for the next one, I will not put it again. I only put one time. So I used a weighted set. And here also the weighted set. This is for checking zeros. Yeah. If I find a land, I will just go put it inside the queue and check for the next iteration of the queue. Yeah. Finally, I need to check the count. If the count equal to target, I'm gonna return result. Otherwise, I'm gonna return infinity. And here is just a brute force to check. This is the result. So if the grid RC equal to 0, if I find one of the land, I'm gonna check the minimum of the result. Yeah, finally, I return the result. If this result not equal to infinity, otherwise I'm gonna return -1. Let me first run it to check. Yeah. As you can see, it passed some of the testing cases, but it cannot pass all the testing cases. So this means I need to optimize a little bit for this kind of code. Of course, this is difficult to optimize because I believe in all the testing cases, there will always be more land than buildings. As you can see, it is always be more zeros than ones. So for such kind of a problem, maybe we can use the second method. But even for the first method from 0 to 1, we can still solve it by optimizing some of the code. As you can see, there are so many zeros. Yeah. Now, well, I need to optimize the code. First of all, I need to check the areas. Yeah. So for this R and C invisited, if the grid R and C equal to 0, I will set it. Yeah, because here is an else. If this count equal to target, it means I have already found 3 buildings. Otherwise, it means from the land I didn't find 3 buildings. It may be 1 or 2 or 0 buildings. But what I can do, I can set all the grid RC equal to 2 if the grid RC equal to 0. Yeah, because the grid RC can also be 1. I cannot change once So I have to check. If it is a 0, I will set it to 2. So this is what I explained about this area and this area. Yeah, if there is a 0, I will set it to 2. So for the next iteration, I will not check these areas, and I will not check these areas and these areas. I just checked one time. So this can save some time. But the final time complexity is still r squared and c squared. So this is r and c. Yeah. Now let me just run it to check if yeah, it works. As you can see, it works, but it will still be time limit exceeded. Yeah, because even we optimize the code, we believe it can pass, but actually it is not. It means we need to optimize further of the code. Yeah, as you can see, it passed more of the testing cases. Right now it is 80. Yeah. Now we can optimize this weighted set. So for most of the BFS problem, yeah, if you are reaching the time like 10 seconds, maybe you can just optimize the weighted set. It can save the time and let you pass at least for this method. Yeah. Now let's try to optimize the weighted set. So before I set a weighted set like this. Yeah. Now I need to basically I need to optimize the weighted set. So I will not yeah, so from here I will use a weighted set. From the beginning I will set always be the false. If I wasted one of them, I will set it to true. Yeah, so this is the queue, and here I will prepare a wasted set. So the wasted set will be a matrix, because the matrix can save some time, the time. So I will use a false times c for r in range capital R. Now from here I need to change it to weighted set. If this is not in weighted, and I just need to check if it is not weighted with row and column. Yeah, so if it is false, I will set it to true. So the weighted row and column would be true, and here will also be the same. Yeah, now in these areas I need to change it to the weighted set. Yeah, so for r in range R and for c in range C, I need to check the grade. If this one, yeah, if the grade RC equal to 0 and visited R and C, this means it is true. It means some of the coordinates like R and C has been visited. It's similar like inside the set. If it is inside the set, I'm gonna set the grade R and C equal to 2. Yeah, this is just to change the weighted set to a weighted matrix, because the matrix saves some time. Yeah, because the set you're gonna use the method like add and pop out. It will always consume some more time. But if you use a matrix, you're gonna just use the weighted like R and C. It will save some time. Yeah. Now let me run it. As you can see, it also works. Yeah. Now let me submit it. Yeah, as you can see, it works, but it takes more time. It is to the limit. Yeah, because for Python, it may be like 10 seconds. If it is more than 10 seconds, you can never pass. So here is like 7 or 8 seconds. But as you can see, it is at the end. Nobody have such slow time. Yeah, basically. So it means this kind of a method can be right, but you have to optimize a lot to let it pass. Yeah. So this is one optimize from the else part, and another optimize about this visited matrix. So we're gonna use the matrix. Let me check here. For here, because yeah, if we make the code totally correct, normally for this visited visited matrix, we're gonna set the visited matrix R and C to true. Yeah, I think in this way it's gonna be totally right. Yeah, if we didn't set, it is still okay. Yeah, but just to make the code completely right, I will set it to true first. Yeah, because basically I will set everything to true. Yeah, now let me submit again to check the speed, the time. As you can see, the time nearly the same. It's the same. Yeah, 7 or 8 seconds. Now let's try to use the second way to solve the problem. Yeah. So for the second way, we are not going to check it from the land to the buildings. We just imagine that there will be less buildings and more land. Maybe, yeah, it is still, we have like 3 buildings, but there will be more land and more obstacles. For example, this is 2 like obstacles, yeah, and all those areas would be land. So why not we just check from the buildings to the land? Yeah, but for that way, we need to prepare another matrix. So first of all, we're gonna prepare a distance matrix. Yeah, so the distance matrix is basically to check for each of the positions what is the distance. For example, this position, we just set it as this position. So for this building, let's make building 1, 2, and 3. Let's make building, yeah, let's make building A, B, and C. Yeah. So for building A, if A reaches this area, just make this area to be here. If the distance is 2, we're gonna set it to 2. If B reaches this area, it's gonna plus another distance, maybe set it 3, or 1, maybe set it as 4. Yeah. So we're gonna check all the possible distance. Maybe this is 8, maybe this is 7, this is 9. Yeah. Finally, we're gonna calculate the smallest distance. Yeah. So we're gonna return this 7. But we also need to make sure that for each of the positions, it can reach all the buildings. So we're gonna need another matrix. So this matrix is gonna be the count. Yeah. So the count matrix is just to check. So for example, in these areas, we need to check if this position, if this land can reach all the 3 buildings. Yeah. If this building can reach this land, the count here would plus a 1. If this building can reach the land, 1 would plus another 1. If this can reach the land, it would plus another 1. So finally, this is gonna be 3. So inside the grid, it will be 3, 3. Maybe this is 2, this is 1, this is 3. Yeah. But we only need to check the result of the 3. Yeah. So we need to check 2 matrices at the same time. One matrix is the distance, another matrix is the count. So the count should be equal to the target. The target is 3. And also, we're gonna check the minimum values. It's gonna be 7. So this is the second method. Except that everything would be the same. It is just BFS. Just we are going from the building to the land. So the building to the land, and this building to the land. And we're gonna have a record of the distance and record of the count of the buildings. Yeah. So the count of the buildings is 3, and here this one gonna be 9. But we will check the smallest value. It is this is 7. Yeah. Now let me go to the code editor. So I'm gonna just copy some code because there's too much codings. Otherwise, it will take even more time. Because I think the best way to solve the BFS problem is to understand the method of how to solve it rather than by remember the code, because the code is just a template. It should not be so difficult. Yeah. Now let me just copy some of my submissions. Yeah. Let's try to find a better way. So this is the second method. Let me try to from here. So I'm gonna use the code from here. Let me copy it and explain it. Yeah, now we are just checking from the buildings to the land, but we're gonna prepare some other variables. So this is just a queue, and this is the count. This count is for count how many buildings in total. So for example, we have 3 buildings, and this count would be 3. And the distance, as I explained earlier, the distance is just the distance at each position. We're gonna prepare a distance matrix and count matrix. Count matrix is to check how many buildings can reach from each of the land. Yeah. And the result is the final return. Let's check the outer loop first. So we're gonna check from R and C, and if the count equal to the count, for example, the building count is 3, and the distance is less than the result is infinity. If it is less than, so the result would be the distance R and C. So finally, it would be the same. We can return result if this result is not infinity. Otherwise, we're gonna return a -1. Now let's go to the main part of the BFS. So from here, it's also the same. I just use I and Z, R and C. If this grid equal to 1, it means it is a building, so I need to count it. So in total, the count would be 3. That is why I use this count equal to the counts R and C. Yeah. Now I put the first one. If it is equal to 1, I put the first one inside the queue. And for the visited set, I'm gonna prepare a visited matrix, because the matrix always saves the time than the visited set. Yeah. Now I'm gonna just check the queue, and we'll take it out and check the directions. If it is inside the boundary, and if this row and column is 0, and the visited matrix is false. If it is false, so yeah, we're gonna prepare the count matrix, distance matrix. So the distance matrix is the dist plus 1, because the dist is starting from 0. Yeah, and the queue should append the dist plus 1, and the visited set would be set to true. Yeah, as you can see, maybe this kind of code is easier compared with the first one. Yeah, but you have to think about you can go from the buildings to the land. Yeah, because for the straightforward solution is just like the brute force. We're gonna check from the land to all the buildings. Yeah, but if you can think reversely, like from the buildings to the land, the coding is much easier, but it's difficult to think. Yeah. Now let me just run it and submit it to check. Check the time. Now as you can see, it's much faster than before. It is like 3 seconds. Yeah, but why it is faster? For the time complexity, it is the same. It is R square and times C square. But why this is fast? So I think maybe it's like the common sense, like the real problem. If we are making a building and land, and there's also obstacles in an area, there must be less building and more land. If there is less building, so of course the second way would be much faster. So if there's less land and more buildings, maybe, yeah, the second way will be slower. Thank you for watching. See you next time.